Hello everyone and welcome to the next lesson. So this lesson is going to be a bit different. We're not going to learn any new material. In fact, we're going to be reviewing everything we've learned up till now and kind of tying it together into a lesson. So I found this website, caveofprogramming.com/java/beginners blah 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 blah. I'll put a link in the description. But basically, this is a really nice. I found it to be a very nice, easy but informative way exercise for us to kind of do together, and you can obviously do this on your own, but this lesson will kind of serve as kind of like the solution to everything with some descriptions and kind of further understanding. If you ever get stuck, you can kind of refer to this video on how to do it because he's got the answers right here, but maybe you need a little bit more explanation. So that's what we're going to do. And we're going to open up, oops, not Godot, sorry. We're going to open up BlueJ. And we're going to create a new project. Nope, no, don't open the project, damn it. And we'll do a intermission example, intermission practice. All right, we'll close the other project. Keep this one open on the left. Let's keep this open on the right. Create a Java program that simply outputs the text hello world when you run it. Call your main class application. All right, so new class, call it application. Y'all know what to do. Delete everything. And we have to start with our main method, public static void main string, no, args, and simply print hello world. System.out.print, is it capital S system? System.out.print line hello world. Is that right? Bam. Public class application, public static void main string args system.out.println hello world. So if we run this, compile, and then we right click, run the main method, hello world, perfect. Now let's clear this, close this, move on. All right, create a class and an object. In the same file as your main application class, define a new class called person. I really don't like that he does this, but we're going to do it anyways because this is the way he does it. Create a new class called person. All right, public class person. You don't need to put anything in the class. Right now, below where you put output hello world in your main method, create an object from that class. Actually, you know what? Forget it. I want you to not do this, but I do want to. What is going on here? Person is public. Oh. Class person is public, should be declared in a file name. So we should do. Don't make it public. It'll be protected or private. But I actually don't want you to do this. I do want you to know that this is doable. You can do this, but you can't have it be public. And the reason is because then Java will get confused as to which one the file is calling. Because if you want to access this class, right, the class is actually called just application. So actually, let's navigate there real quick. Let's see if I can find it first of all. Documents. Let's see if I can find BlueJ. Let's go to C. Users. That's me. BlueJ. Nope. Where the hell are you? Intermission practice. Perfect. So you'll notice that there's the java.class. This is the actual file we're editing, right? So if I actually right click this and open with, can I open with? There we go. Open with. Forget that. Open this. Notepad. Right? Oh. Maybe it's the Java one. No, don't do that. There we go. So the Java file is the actual file that we're editing. And notice that if I open it in Notepad, it's the class itself. However, the class is called application. So if we want to access this file, we have to tell it what the file name is. So when we call a class application, we're actually calling the file name. But then it looks inside the file and says, okay, fine, this is the application file. Then give me the application class. But that means that you can't have a person class and an application class both be in the same file. This is very, very rare to put two classes inside the same file. It's very possible, it's very doable, but the second class you put in there is going to be accessible only from the first class. So this second class might be useful for something like an ARM class or whatever, but even then you really wouldn't do anything like that. You would just have everything be its own class itself. And that's what I want to do actually. So I do want you to understand that you can put a class here, but we're not going to do that. So let's make a class called person. And like he said, make it completely empty. Perfect. And we're just going to compile the whole thing. Okay, so right below, or in our case, in a new file, output hello world in your main class, create an object from that class. So the class is called person. So if I want to make a new object from that class, we need to first define a variable of that type. So we do person and then me equals, I need the new keyword, because remember that the new keyword tells Java that I'm making a constructor call. Because doing person like this without the new, Java will complain because it thinks that person is a method, not a constructor. So by putting the new in front of it, we're telling it to call a constructor called person. This way it knows to go to a class called person, which is that other file, go to its constructor and call its constructor. Now remember that there's no constructor here, so what are we calling? In the last lesson, we learned that if you don't have any constructors, Java will give it one constructor called the default constructor, and that's exactly what we're calling right here. It has no parameters, and in our case does absolutely nothing but creates the object, throws it into memory, and stores the pointer in here, which is the very bare minimum of what we can do to make an object. All right, here's a little hint. Although you can only have one public class in each file, you can create as many other classes as you want in here, just so long as you don't use public keyword to use them. That was my mistake at first, but we corrected it. Usually, of course, you can put classes in their own files, but here we put in the same for convenience. We're not doing that because that's bad practice in my opinion. He does this to teach you something, and that's perfectly fine. I just disagree with it, that's all. So basic constructors. Modify your person class to add a constructor. Make the constructor output the text constructor running. So how do we make a constructor? Right, we say public, and then we just do person. And we'll just output system.out.println constructor. God, I can't type. I can never type when I record. Constructor running. All right, system.out.println public. Okay, perfect. Is this right? Shtablam, right? Person. Constructor running. System.out.public person. So there's our constructor header, actually, and then our constructor body, just output constructor running. So now, if we run this, it will actually print hello world, and then once we create the object, it'll say constructor running. Let's go ahead and run this. And we can see that since the application is calling the person class, we have a little arrow there. This is the nice thing about BlueJ. This will visually show you exactly what's going on in terms of calls and instantiations, etc. So let's compile, right click, void main string args. Good. Hello world, constructor running. We're doing well. Moving along very quickly. Multiple constructors. Modify the person class so that it has another constructor in addition to the constructor it's already got. Make the second constructor accept the parameter called name of type string. All right, public person, remember it has to match the name, and then string name. All right, that's the first thing. Now make the second constructor print the name parameter. Make the second constructor print the name parameter using system.out.println. System.out.println name. All right, we're going to print the name. Finally, change your main method so that when you create the person object, you pass in a name. Pass in your own name, in fact. All right. Ben. And that's it. So now we've changed the constructor call. The constructor call, and we're sending it one string. If we look at the list of constructors, we have two constructors. This one takes in no inputs or no parameters. This one takes one, and it's a string. So this is the constructor that it's going to call. If I delete the string from here, we're going to call that first constructor, but that's not what we want to do. So I feel confident that it's going to work, but if you want to see it anyways, oops, where is that? There it is. Hello world Ben. I ran it twice by accident, but that's okay. All right, instance variables. We're cruising along through here. Instance variables, also known as data members. That's true. Modify your person class so that it is private. I don't know why I said that. Modify your person class so that it is private instance variable called name and of type string. All right. Modify your person class so that it has a private string name. Instance variable, so it's non-static. That's what he means by instance variable. It is a non-static variable. Using the name parameter that you pass in. Oh, sorry, in the second constructor, set the name of the name instance. Now we did this before, right? Inside the scope of this person constructor, we actually have two variables called name. We have the one that's the class variable or the instance variable. Since it's non-static, it's an instance variable, but we have one at the class level. And we also have one that's inside the constructor level, right? So how do I specify one from the other? Well, since it's an instance variable, I can just say this dot name, which refers to the one inside this object, equals name. And without the this in front of it, it's referring to the more local of the two. All right, in your second constructor, set the value of the name instance variable using the name parameter that you pass in. Remove the system.out.println in the person's class. So remove this. I think he means that one. He might mean the other one too, but I'm pretty sure he means this one. Okay, there's a problem here. The constructor has two variables called name. One is a parameter, blah, blah, blah. Use the word this. Methods are a way of making subroutines part of the object by defining them in the classes, of course. Add a method in your person class called writeName. Make the method output the text, my name is, and then your name. All right. Public, what is the name of this? Let's say it's void because I'm assuming that we're not going to do anything with it. writeName. Right, I don't need any parameters because I'm already going to have the name. All we needed to do is print my name is and then our name. I don't need any parameters because I already have the variable accessible to myself. So I'm going to do system.out.println. My name is. Don't forget the space after is, otherwise it'll just put your name directly attached to is, and then name. Right? Your program should output, my name is Topsy, assuming your name is Topsy. Well, my name's not Topsy, so compile, run. Oh. There was a step that I must have either skipped. Oh wait, we didn't actually call it. Invoke, in the other words, or call this method in your main method. So I have to call this method. That's what I forgot to do. I have to call writeName. But remember that the method belongs to the instance that we created. The instance is called me. Not person, it's me. Person is my variable type. So me, if I just do me.writeName, that is not correct. There we go. That is correct. Compile, right click, run. My name is Ben. So let me walk you through what just happened step by step. System.print hello world. So we're going to print hello world. Then we're going to create an object called me, throw it into memory, call the constructor that says Ben. Well, we call the constructor which makes it into memory, throws it into memory. And we pass the name into the instance name, the instance variable called name. At the end of that line, we now have an object sitting in memory that has a string variable in it called name, and that name is storing the string Ben. The pointer is stored in the variable me. Then I call that object. I say, hey, go to me, the object called me, and call the write name method. Because this is a non-static method, I can call it from me. And the only thing that this method does is print my name. My name is Ben. Get and set methods. In prehistoric times, get and set methods, also known as getters and setters, were known as mutators and accessors. That's true, no one calls them that anymore. Or at least they might still call it that, but I don't see anyone calling it that. I don't ever hear it. Add a get name and set name method to your class. Perfect. So let's think this through. We want public. I want to set the name. So do I need to return anything back? You can, but for us, no. We want to take in something. So set name. Come on. String name. Where's that button? There it is. And then this dot name equals name. Maybe we want to change the name later on. I don't know. But making setters and getters for every variable is very common. Public. And then now that I want to get the name, right? So if the main method calls the method, this method, it wants to return the name. So now I do need a return type, and it needs to be string get name. Son of a bitch. There we go. And then I return name. Now notice that I'm not using this dot name because there's no variable inside the scope of this method that's called name except for this variable. See, in this method, the person constructor, sorry, not the method, the person constructor and the set name method, there's two variables called name. One in the parameters, one defined in the input parameters here and here, and also the one that belongs to the object. That's why we have to use this dot name. Technically, I could use this dot name also here and it won't break anything, but it's overly redundant. It's unnecessary, but it still works. All right, add a get and set name. Modify your main method like this. Use get name to retrieve the name string from the person object. Okay. And then do what with it? Store it there temporarily. Okay. I guess first name, I don't know, something. Someone's name equals me dot get name. Use get name to retrieve the name string from the person object. Store it there temporarily. I guess this is what they mean. Add a space followed by your surname to the string you just retrieved. So someone's name, oops, that should not be capitalized. Someone's name plus equals a space. Use the set name method to set the name instance variable of your person object to the full name that you've just created. Oh, followed by your surname. I was wondering. Space Bob. My name is Ben Bob. And then I want to use me.setName and then pass someone's name, right? Now I can actually simplify this. There's actually a couple ways I can simplify this. So let's simplify this a little bit more, and I'll just do get name plus space Bob, right? Space Bob. And I can actually delete this, right? I can even go a little bit further. So first, let's look at this. I go string someone's name equals me.getName plus space Bob. I store that, and then I just send that back to this method call. I could also actually, yeah, what I could also do, even this is not what he asks you to do, so this is not going to show up correctly. What I could also do is do me.setName equals me.getName. Yes, I can call the method from here plus Bob, right? This actually, all three of these have the exact same outcome. I'm getting the name, which is Ben, plus, and I'm adding space Bob after it, and then using that result to send it to set name, right? I wanted to show you that you can call functions or methods inside of as a parameter inside of this. Just take it one step at a time. Go from the inside out when you do this, right? Me.getName it returns a string, right? Ben. And then I'm just adding another string to it. In the end, it's going to be Ben Bob. Ben Bob. And I'm sending that whole thing. Ben Bob is what I would, replace the blue with. Ben Bob, and then doing me.setName, which goes down here and then sets the name in there. So that's how I'm going to do it, just for the sake of confusing you. Use the set name and then the full name. You do all this just before calling write name. And then me.write name. Hint, none of this involves editing the person class. All your editing should take place in the main, which is exactly what we did. Your program shall output, hello, my name is blah, 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 blah. Compile. Hello, my name is Ben. My name is Ben Bob. Let's actually clear that since I've confused myself as to where it started and where it stopped. Hello, my name is Ben. My name is Ben Bob. So why did it do that? Remember that the person class, when we call the constructor, outputs. Actually, no, that doesn't. Hold on. Oh, because I still do write name, and then, so I don't need this anymore. I call the write name twice. And this should get me to where I need to be. Whoops. Hello world, my name is Ben Bob. Composition. Finally, the challenges to end all challenges. This last question is the bad guy at the end of the level. Above where you defined the person class, define the class called brain. So I'm just going to create a new class. I don't want you guys putting classes inside of classes. All right, so we have a brain class and a person class. I don't know where he's going with this, so let's just kind of delete everything and start from scratch. Give the brain class a constructor. Make the brain constructor print the text thinking. All right, public brain. He didn't tell us to put any parameters. All he said was I wanted to print thinking with 3 dots. System.out.print line. I'm assuming it's a print line. Thinking ... and then that's it. Give the person class a private instance variable of brain. All right. So private instance variable. Now, because it's a private and it's an instance variable, we need to make it at the class level, and it needs to be non-static. So, and it needs to be of type brain, because that's what it is. Give the person class a private instance variable of type brain and called brain. Oh. In the one parameter person constructor, which is this one, because it's got one parameter right here. Oops, right here. In the one parameter person constructor, set the brain instance variable equal to new brain object. So brain equals new brain, right? We define the variable up here, and then we actually create the we actually call the constructor, create the object, throw it into the memory, and pass the pointer into the variable. And so when we create a new person using this first constructor, or I'm sorry, the one parameter constructor, it will give it a new brain. If I call this constructor, I don't get a brain. Your program should output like this. So let's look at the application. Yeah, so it should still work that way. Thinking my name is Ben Bob. So actually, let's break that down a little bit because I want to point something out. Let me clear everything, run it again, and see if we can kind of reverse engineer the exact process that's going on. So first, in the application, it says hello world, right? System.out.println hello world. Pretty simple. On the next line, we create an object called me. Then we call the person constructor, passing it Ben. So if we go to that constructor, which is this one, first thing we do is we set the name. That's it. We didn't print anything yet. We just set the name. On the next line, we create a brain object. So we go to brain, and the first thing that happens in the brain constructor is it prints thinking. That's why thinking is next. Then once we're done, we return back to this. Well, there's nothing left in the person, so we return back to this. And the next thing is we set the name, right? I get my name, add Bob, and then do me.writeName, which is my name is Ben Bob. That's it. That's exactly what happened. So the main method starts us, we go line by line, we go down the rabbit hole from class 1 to class 2 to class 3, back to class 2 to back to class 1. Whew. All right, once you're able to do this kind of stuff from memory, you've got a decent grasp of the absolute basics of class and objects in Java. Of course, there's a lot more stuff to learn, but this is a great foundation to work from. Okay, so that was a pretty quick kind of practice problem that we had there, but I want to cover a couple things, and then I actually want to talk about a few things that I was saving for the next lesson. The first thing I want to mention is that this example doesn't use static anything. There are no static methods, no static variables, or anything. That's kind of okay for now, but I want you to understand that all the variables and all the methods that we've made are non-static, which means that they belong inside the object itself. So if I open up a whiteboard to try to draw this out, I'm sorry if you're tired of watching me draw stuff because I'm bad at it, right? But if we pretend that we have the application class, which we'll just call app, right? At some point, the application class calls the person class. That's a lot nicer. I didn't know my hand could rest on the screen. Hopefully that doesn't screw things up. Anyways, and then we have like a brain class, but let's kind of forget the brain class for just a moment here. Inside the person class, we have the person constructor. And from the person constructor, when we call the person constructor, we just make a person object called me. And it's got a name. And because it's non-static, it actually gets inside the object, right? So actually in here we have a me. There's like a pointer called me. And it points to this guy down here. Holy shit, that was a bad arrow. I'm making it worse. Stop, Ben. All right. But the name variable isn't in the person class. Yes, we defined it when we created the class. But the name variable doesn't belong to it. It can't use it. We can't call person.name. It doesn't make any sense. If I wanted to give the person class its own like string variable, I would have to do private. Whoops. I would have to do private static string name or private static string whatever. So if you want this to like keep track of number of persons made, I can do private static people created, right? As a just a integer variable that I'm going to store into it or something like that. So there are no examples of static variables used here. That's the first thing I want to cover. But I do want to reiterate how they work and what they are. The next thing I wanted to kind of further explain was what was going on with that Java class and the Java file. So if I can remember where the hell I even was. Yeah, C, users, and then intermission practice. Cool. So now you'll see that there's 3 files for every class. There's an application.ctxt, there's application class, and application.java. If I right click the application.java and open with, oh no, shit, damn it. Okay, whatever, I can delete that later. Anyways, the application.java is what we actually wrote. It's just a text file. Obviously, I can open it in Notepad, which means it's literally just a text file. It's when we hit the compile button, Java will run it through the compiler and write it to the application.class file. This is why we couldn't read it. If I open this with Notepad, you'll notice that it's all garbled. That's because this is no longer simple text. This is bytecode or Java bytecode, or what is it called? Yeah, I think it's Java bytecode or whatever it's called. Anyways, this is what the Java runtime environment or the just-in-time compiler, this is what this is going to read. And you can't read it because it's not actually in characters. It's not text. It's converted into lower level machine pseudo like machine code. You can actually see that there is a few things in here, but this is all like just kind of reference crap. But that's what that is. Like you have, this is what you write, this is what the compiler outputs. This must be something else that I'm not sure, and to be honest with you, I could care less. But that's it. So let's actually try to run this in another way. Another thing I want to kind of point out, so that's done, right? So you understand that this is the Java file, this is the class file, this is what we write, this is what the compiler outputs. So all these .class files are what's actually being used during runtime. Hello everyone. Sorry about this little blip in the video. I kind of lost some audio and had to kind of start over. It's been a whole week. It's a long story, but I'm back, and so let's kind of continue where we left off. The thing I was going to show you next was what the heck happens every time we run this program. We get this little window called the terminal window, right? Or just the terminal, if you will. What is that? How does this kind of play into the way that someone else would use our program? Because remember in Java, you can build it anywhere, you can create it anywhere, and then, or create it once and then run it anywhere. So how would someone else run our program? And the answer is the command line interface. If you're on Windows, the command line interface is called the command prompt. If you're on Linux, it's called the terminal. Actually, if you're on Mac OS as well, it's called the terminal. So the command line interface is the original way that computers used to be, well, interfaced with. This is how we used to talk to computers and how we used to communicate with them and execute commands and build programs and something and so on and so forth. This is how your this is how your friend or someone else would run the program. But there's a few things that we should cover before going into the command prompt. The first thing is that throughout the last week, I kind of tested something because I noticed that something wasn't right. If you open command prompt and you type in Java space -version, you'll notice that one of two things will happen. Either it'll say Java version and then in double quotes it'll have a version number, or it'll say error Java is not a known command. If it says error Java is not a known command, that means you don't actually have Java installed. So how can we be using Java when we have BlueJ but not have Java installed on the computer? The answer is kind of weird. In the past, BlueJ used to force you to download Java from Oracle, right? It used to force you to download the Java development kit from Oracle, then you would download and install BlueJ. And BlueJ would use the downloaded and installed Java development kit that you just downloaded and installed. But something must have changed over the last couple of years because BlueJ now downloads and installs with its own version of, not its own version, but it's the most up-to-date version of the Java development kit. And the thing is, it doesn't install the Java development kit, it keeps it for itself. So therefore, it never actually tells Windows that it's installed. So this way, when you run BlueJ, BlueJ will know that Java is installed and it'll know where it put it because it's going to put it inside of its own folder. Windows will never know about it. So if you see error is not known, that's because BlueJ is using its own Java development kit and Windows has no idea that it was installed. So if you want to follow along, you have basically one of two options. You can either download and install the JRE, or you can download and install the Java development kit. Now, let me kind of explain the two differences here. The Java development kit, actually I'll start with the Java runtime environment. The Java runtime environment, or the JRE, is basically what you install into Windows, and it's what Windows talks to directly, a little bit more directly. So when you open a new program, when someone runs a program, Windows is going to call the Java runtime environment. The Java runtime environment is going to create these Java virtual machines, and the Java virtual machines are the interpreter. So remember on the first lesson how we talked about the difference between compiled and interpreters? Well, when you run a program, the Java runtime environment creates these virtual Java machines, which as if it was its own hardware being virtualized inside of your hardware, right? Anyways, but that's where our interpreter is and that's how it runs. And then it runs your program. The Java development kit has the Java runtime environment, but it also has all of the Java classes created by Oracle, right? These Java classes, by the way, are packaged in packages and groups. So groups of classes are called packages and groups of packages are called libraries. So when you download the Java development kit, you're downloading not only the runtime environment, which is the interpreter, but you're also downloading all of the classes that Oracle creates, but you're also downloading a compiler. And then BlueJ utilizes the Java development kit, in other words, the compiler and the libraries and the runtime environment, and adds the text editor, the compile button, which is just the compiler. This actually talks to the Java development kit's compiler and says, hey, I want you to run it. But it gives you a text editor, and it gives you the ability to, and the text editor gives you the ability to detect bad code and so on and so forth, but that's BlueJ. So that's where BlueJ stops, and then the Java development kit starts. So that's basically it. When we create a program, we use the Java development kit. Let's say, now the Java development kit comes with all of the classes that Oracle has, maintains, creates, etc. When we make a program, we're going to pull copies. We're going to copy some of those classes, bundle them up in our own program, and output that to a folder or the internet. Someone else can download it and then use their Java runtime environment to run the program. So a couple things that I want to note there is that you don't always have to use the command prompt, although we are going to now. You could also output something to a Java executable called a Java archive or a jar. You can make some of these archives executable. We're not going to do that now. I'll do that another time. But this is using the command line interface is basically how you would do it. Anyways, I went on way too long about that. So there's the Java runtime environment and the Java developer kit. If you Google Java runtime environment, because you just want to run programs, because you're just going to use the Java development kit that BlueJ comes with. If you want to just use that one, that's fine. You don't need the Java development kit. Uh, you're probably going to run into one of two pages, either this one or this one. The problem with both of these pages is it's Java 8. We're on Java 16. I don't know why, but this is the one that comes up first if you just type in JRE download. If you type in JRE, you might get this page. It has the same file, but this one requires you to log in and pay for it. Because I think that this web page is for companies to use, right? Because according to their new license update, you have to pay to use Java if you're a company, if you're a business. If you're the individual like you and me, probably, then you don't need that. You don't need to pay. But I would prefer that you not use that. So either download the Java runtime environment number 16, version 16, or if you really want to follow along, Google JDK download and download this one right here. So it should say Java SE 16. I think it's standard edition 16. And then do this download right here. Download and install it. Once it's done, restart or close and reopen a new command prompt. And then type in Java space minus version. And you should see 16.0.1 or something else. I don't know when yours came out. I don't know when you're watching this video. But it should say a version number, basically. If you see a version number, you're good to go. So like I said before, you won't be able to use, did I say it before? I re-recorded this so many times. Anyways, if you use Java 8, you won't be able to use ours because BlueJ, the one that I downloaded, is using version 16. This is version 8, and so is this one, so these two are not going to help. So back in the command prompts, we should be ready. We have the Java development kit installed, which installs the Java runtime environment. We now understand the difference. We understand the command prompts. Maybe we don't understand the command prompt, but that's what. Let's learn something about the command prompt before we can use it. I have this list of commands, and I just want to point out a few common ones. The command cd is change directory. The command dir is print directory, or print everything that's inside the directory. A directory, by the way, is a folder. It has absolutely no difference than you opening up a window file browser and looking at files like this. This is essentially this. This is just a graphical representation of this. So if I click here, you can see that this file browser is in C users wise guy intermission practice. On the left, the command prompt is in C users wise guy. So if I do cd, which remember stands for change directory, space, and then I'm going to type in intermission practice, but I'm only going to type in part of it, intermish, and then I'm going to hit tab. You'll notice that Windows auto-completes it because it's like, you know what? I can see that you're typing this. The only thing it matches is this one folder. I'm just going to auto-complete your sentence. Then you're going to hit enter, and you'll notice that this little caret, right? This the ket, right? Bracket here, or the greater sign, moved all the way to the end, and now it's C users wise guy intermission practice. So this is the folder we're in. If I type in dir, it'll print everything that's inside of that folder. So we have application.class, and take a look, application.class. So that's it. So mk directory, mk dir, by the way, can do make directory. We're going to make a folder, and I'm going to call it hello. Hit enter, and on the right hand side, you'll see the folder hello pop up, but go ahead and delete that because I don't want that sitting there. Okay, so how does somebody use this? So if you have the .class file, you can run this by just doing Java and then application. Get rid of the .class, by the way. When you hit tab, Windows completes the entire name, including application.class, but you need to delete that because the Java runtime environment doesn't want the .class. So hit enter, and you'll see that it says, hello world, thinking my name is Ben. Okay. So the next thing I want to show you is I want you to delete the ctxt and the .class file. By the way, the ctxt is something that BlueJ creates. This is not something that's unique to or special or specific to BlueJ itself. It's something that BlueJ. It's not something that's specific for Java. It's something that's BlueJ specific. So it's really not important. You can leave it or delete it. I want to delete it. I'm going to delete the .ctxt and the .class file. So now all I have is the .java file and all these other ones. Now in the command line, I want to type in javac, which stands for Java compile, and then I want to type application. Now I want to include the extension. So Java and then application without will run the program. Javac application.java with the extension will compile it. So on the right hand side, you just saw that application class popped up. And again, obviously, we can do application, get rid of the .class, and then, hello world thinking my name is Ben Bob. There we go. Now, I could make a class by just going to new and then text document and doing something like CMD example. You also, remember, need to change it because the compiler only compiles .java files. Windows will complain. Do you want to rename CMD example to... Oh, I already have this? Oh, shit. I didn't delete this from the previous time I recorded this video, but that's okay. Just replace it with .java. Windows is going to complain saying, it's like, hey, you shouldn't change extensions. And it's like, yeah, I don't care. I want to. So open it up and make a quick class file, right? So how do we do that? Public class CMD example. And then public CMD example. Actually, no. That's a constructor. I don't want the constructor. Just do public static void main string args. By the way, the tabs don't matter. We can actually do this and it'll work, but this is just not very readable and it looks kind of ugly, so that's why I'm still tabbing over. You don't have to technically. And then system.out.println. Actually, you know what? I want to show you how to do inputs real quick. So I'm going to do. I have to memorize this because remember we're in Notepad, so we don't get the opportunity for something to tell us that we made a mistake until we compile it. So let's say I do import java.util.scanner. I believe that's what it was, right? That's the scanner class. And then it's scanner in equals new scanner system.in. And then system.out.print line. Nice to meet you. Actually, let's do a string. What he said or she said equals in dot next. Next line, no, next. And then let's actually just print that out. And then we'll just type in what he said. And then I want you to save it. And then on the left-hand side, we actually might have to close the file. But so let's just close it. Let's do javac cmd example dot class, no, dot java. Yeah, dot java. Wait, okay, we're gonna delete this. I forgot to delete that from earlier. Bam, no errors, sweet. So I'm gonna do java cmd example dot class, delete the dot class, run it. So it's blinking, right? Nothing's outputting, because remember the first thing we did was demand an input. So I'm just gonna say hello there, everyone, and it's gonna repeat hello because apparently the in.next just reads the next string, I guess, and I guess the spaces matter here, or it must be the next word or whatever. So let's actually compile this to be next line. I think that's right. Java C cmd example dot Java. Good. And then Java. I didn't save it. I'm an idiot. Java C cmd example. Oh shit. Dot Java, not dot class. Class usage Java C. So here's an error. C users was guy blah blah blah. Line 8. Cannot find symbol string what he said equals in dot next line next ln. So let's Google that real quick. Java in dot next line. I just put a space there. I should not have done that. Oh, it's literally next line with its capital L. Okay, save it. Now I can actually hit up on the arrows and then it'll go to the last command. So that was the compile. So now it worked. And then we can just run it again. Delete the dot class, and it's waiting for us. Okay, so now I say hello there, everyone, and it repeats it. And then it ends the program. So that's how you do inputs. That's how inputs look. This is an output. We built our program in the most simple text editor, the second most simple text editor there is, Notepad. However, if you're on Linux, you can actually edit the file from the command line interface. Windows used to be able to do this, but they actually got rid of it. That's why I can't demonstrate it, and that's why I had to make a new file. It's because Windows no longer has the ability to edit text files from the command line interface. They got rid of it, which is unfortunate because I kind of like using the command line interface for that reason. Anyways, the last thing I kind of want to talk about, actually, 20 minutes, I think I have 10 more minutes left of this. So the last thing I want to talk about is file structure. So you can push this out of your way. Forget about the command line interface. Forget about this. Let's talk about packages, right? So let's talk about packages and let me explain kind of how things kind of work. I'm going to talk about it lightly because I think I have an example later on that'll explain packages a little bit better. And I'm running out of time. I only have 10 minutes left of this video. I want to keep things to about an hour per video. So anyways, Java packages. Geeks for geeks. All right. So packages are basically the organization of classes, right? So you have libraries and you have classes. Oh, I'm sorry, packages. God, I'm so tired. You have libraries and you have packages. Java, if you have, let's say I need a file from the Java library. In other words, the very big package from Java or Oracle, right? So there's going to be the Java library. Inside the Java library, there's going to be groups called packages, right? Or I might have that backwards. Built-in packages, java.link. Nope, that's right. So Java is the whole library. You can find libraries from other companies that'll probably say their company dot and then something else. That something else is the package. So in Java, we've seen java.util. We've seen java.system. I think java.system. Java.whatever, java.whatever. These different things after the first Java are the packages, right? One package is for network communication, one package is for gaming, another package is for math things, one's for science, one's for physics engines, one's for whatever, right? So the first one's the library. The library is a group of packages, and there's multiple packages inside the library. Each package is going to have a group of classes. The classes, if they're built properly, the packages will have classes that are obviously relevant to utility, right? Vector is relevant to the utility package, and the utility package was built by Java, so it's inside the Java library. So basically all this is actually just a bunch of zip folders that I'll show you on another class, but it's basically just uh, it's actually quite literally a zip folder, but that's besides the point. So how do we find these? You can actually Google Oracle Java library. So docs.oracle.com. On the left-hand side, you'll see the entire Java package. So all classes. So these are all the different packages. Java is the class. Sorry, Java is the library. There's the AWT, AWT.color. I think AWT stands for Abstract Writing Tool and is used for graphical user interfaces. There's IO. There's .lang. There's .math. There's all kinds of packages. Take a look around. There's tons of them. And then here are, if you were to expand all of these packages, here's all the classes that exist. Right, so let's kind of just stop and click on any one of these. So let's try, I don't know what output keys is at all, but let's kind of look at this. You can, up here at the top is just ways for you to navigate forward, backwards, and around in the website. Right underneath it, you're going to see this. This, I want you to ignore. This java.ling.object is going to exist for all of these, but I'll explain that to you later when we talk about inheritance. Underneath it, though, you'll see javax.xml.transform.output keys. JavaX, was JavaX Oracle's XML library? I think that's what it was, but I could be wrong. JavaX is a separate library, still made by by Oracle, but there's a package called XML, and then inside there's another package called Transform, and inside that package that's this class right here, the output keys class. So this is just showing you where it is inside of it. So in your program, if let's say you wanted the output keys class, you would have to do import and then this entire line. That's what we've been doing. If you want to use multiple files from the same package, you can just do import javax.xml.transform.star. Star is called a wildcard. I don't think it'll install, when you output your program, I don't think it'll install every single class that's inside the package, but it will look at I'm not sure if it does that or not. I don't think so. I think it looks at which ones you do use and just pulls them out kind of smartly. No, maybe it does output the entire package, but that would be a waste. Anyways, you can replace output keys with a star if you want to do wildcard because you might need multiple classes from the same package. But after this thing that kind of shows you how to do the import statement, I want you to skip all this because this has to do about inheritance. Down here, it's got a field summary. These are all the variables you can use, right? It's got this. You notice that it's all capitalized in snake case. That means that it's probably, based on convention, it's a final, right? It's a constant. It won't change. In fact, if you click on it, you'll jump to like the near bottom of the web page, and you can see that it's public. It's static, so it belongs to the class, not the instance variables. It's final, so it's going to be a constant, and it's a type string. So there's our field summary. There's actually no constructors, so let's go to another class for just a second here. Oh, you know what? Let's talk about the swing. Let's talk about the swing package. Swing dot. So there's the swing package, and then I want to find the frame, the J frame. So let's just actually take a look at the javax.swing, and that's what the javax is for. That was the I think their graphical library, right? So you have the Java Swing, and inside that Java Swing library, I'm sorry, package, you have the JFrame class. So again, ignore all of these except for the bottom one. This is the line that you have to import. This is all to do with like inheritance, which I'll cover another time. There is a nested class, huh? This is the first time I've ever seen that, but there is a nested class. There's a class inside of this, and it kind of has some information about it. But let's skip that for now because I told you we're not really going to do that too much. Now we have the field summary, so these are all the variables that are inside of it. Don't worry about anything that says inherited. These are variables that it has that comes from other things, but we'll talk about that in 2 or 3 lessons. Just know that these are the variables inside of it. All of these are actually, but these are the ones that we are programmed in just like the way we've been doing it. These are done a little bit differently. Don't worry about it yet. After that, you'll see a constructor summary, right? Here are all the constructors. Ta-da! And then the method summary. Here are all the methods inside of it. If you click on anything, like the field summary or the method, right? So like get class pane, it gives you a description of what this class does. So the point here is to show you what documentation looks like. So in the future, you might be better at finding classes for your projects. I know that's going to take a lot of practice, and for now, I'll help you out. I'll hold your hand. But it shows you how to find the packages, how to find the classes sometimes in a way, and how to read it a little bit, right? You just got to look at this last one. For now, that's our shortcut. Look at the last one. That's our import statement right there. Bam. And then here's our constructors. Here's our variables. Here's our constructors. And here's our methods. So now we know how to completely utilize this class, sort of. The JFrame is a little bit special, but the reason I bring up the JFrame is that something we're going to do in the next lesson. The next lesson is going to be about graphical user interfaces, but only at an introductory level. I want to do graphical user interfaces because I want us to get away from the command line interface. I want us to start making more interesting programs. I don't want you to get bored or lost. I want you to really see that you know a lot more than you think you know. But more importantly, I want you to see the different ways that your knowledge of object-oriented programming can be implemented. Now, we're not entirely ready for graphical user interfaces, but I'm going to do my best to kind of give you an introduction on like just how they look and feel a little bit and how to use them in a very simple way. We will come back to graphical user interfaces once we're done learning about inheritance and events and all kinds of different new topics that we haven't covered yet. Then that's actually probably when we're going to switch over to C#. But let's get there when we get there. The next lesson is going to be graphical user interfaces, and I will see you guys then.